So this part is really new. Usually we always talk about projections into 2100 by the uh, IPCC community assessment reports, but here short-term predictions, what sometimes get called as societally relevant timescales in terms of making decisions. So the predictions out to 2026 are offered, and I really wanted to report that in a podcast, and that's why I'm doing the whole report, even though some of it is repetition of discussions we have already had. Doesn't matter. State of the Global Climate 2018 to 2022 by WMO in the United in Science 2022 report. The key messages here. The 5-year average global mean temperature for 2018 to 2022 was 1.17 plus minus 0.13 degrees C above the 1850 to 1900 average, making it the fourth warmest 5-year period on record after 2016 to 2020, 2015 to 2019, and 2017 to 2021. So natural variability still produces these ups and downs because the latest 5-year period is not the warmest, it's the fourth warmest, but that's because there is also a very strong La Nina that's in its third year, and you know that when La Nina happens, ocean can soak up quite a bit of the heat in the Western Pacific. What happens to it, when will it come out, and so on. Of course, El Nino belches some of it back, and so on and so forth. Ocean heat content, which is the measurement of heat stored in the ocean, was higher than any other 5-year period for 2018 to 2022. So here is the trick. So the global warming may not be the warmest 5-year period. It just means that his heat is going into the ocean, so it's not actually gone out to space. It's still in the system. So that's something we have to always remember. Average sea ice extent in the Arctic from 2018 to 2022 was below the 1981 to 2010 long-term average, and Antarctica reached its lowest or second lowest minimum sea ice extent on record. So this is based on different data sources, so estimates can differ, but no good news there anyways. 5-year global mean temperature difference compared to 1850 to 1900. So this is a 5-year running average of global temperature anomalies relative to 1850 to 1900. From 1850 to 1854 to 2018 to 22. Data to May or June 2022 as was available in each of the products. This is shown as a difference from the 1850 to 1900 average. 6 data sets are shown, and the message is still the same, that uncertainties between different reconstructions were higher in the past, but now they are all reaching essentially the same conclusion, even though the bumps here are slightly different. This corresponds to various methodological differences and so on and so forth, but the warming continues to accelerate, and the La Nina has a little impact here in terms of the last 5-year periods that we already talked about. So if you look at the 5-year mean near surface temperature difference, again from the 1981 to 2010 average now, for the period of 2018 to 2022, data only to May or June in 2022 again. There's a strong wind here. Each map grid cell value is the median calculated from the 6 data sets that we saw here. Okay, so the message is still the same. There are regions where warming is amplified, like the polar amplification, and this region extending from Middle East, Pakistan into the North Atlantic, Mediterranean, and Europe. And the warming hole here in the deep water formation site potentially related to the Atlantic meridional overturning, and we always watch this one. As we said, this is where ocean can take up heat. So if this warms less than the west, the pressure gradient, temperature gradient, winds respond in a way that this can continue to remain cold. Of course, that could be bad news because that produces very dry climate over western North America and western South America, so that's has some consequences, but overall global warming should be modulated by that. And there are other dynamic responses. Indian Ocean continues to warm quite rapidly, and some of the heat that is taken up here is being moved into the Indian Ocean through the so-called Indonesian through flow through this maritime continents and Indonesian seas. Global ocean heat content, as we talked about, there are two reconstructions again. This is a massive number, 10 to the 22 joules. So this is 0 to 700 meters, and from 1940 to 2022, there are differences, and these differences are not small because this is 10 to the 22 joule. Okay, but ocean heat content estimates are obviously severely limited by the number of observations available. Surprising though that they don't differ as much here, but they differ here where there is more data from Argo and so on. So one has to see why there is such a big difference. The message is still that ocean continues to soak up almost all of the heat that is being trapped by the increased greenhouse gas emissions from human activities. Arctic sea ice extent, again multiple products, but also looking at March and September. So obviously March is important because that tells you what has accumulated during the winter, and September tells you what is available to refreeze as we go into fall and winter. So you can see that there is a steeper drop in the September sea ice extent, which is bad news, because ice albedo feedbacks will make it harder for ice to grow back in the winter. And the March here seems somewhat stable over the last decade or so, which has to be watched in terms of why. So this dropped here maybe suddenly and has flattened out with interannual variability. All these details matter in terms of the energy balance and the actual ice dynamics and circulation involved there. Okay, that's a complicated circulation as well, with heat coming below the surface from the North Atlantic and so on. And it's argued also that the cooling here may be related to heat being pulled out on this side and not so much reduced heat coming from here. So those details have to be understood. If you want, you can follow that up. Antarctic sea ice extent difference from 1981-2010 average. So you can see again two products looking at February and September. So it's the reverse of the boreal seasons, austral seasons, right? So you can see that the message here is quite mixed because Southern Ocean warming can increase atmospheric water vapor and increase snow in some places and lead to accumulation, whereas shelf ice, ocean warming, melting from below, sliding of glaciers and so on. Very complicated situation in Antarctica that has to be watched closely because of this ocean land affecting things differently. Global climate predictions for 2022 to 2026. This, I hope, will become more and more common in terms of societally relevant timescales, instead of wasting so many resources on projecting out to 2100 without tracking who is actually using this information or what these uncertainties in scenarios actually mean, and so on. Okay, so key messages here: there is an almost 50% likelihood that at least one of the years from 2022 to 2026 will temporarily exceed warming of 1.5 degrees C above the pre-industrial levels of 1850 to 1900 average. This we saw in the main message as well. There is a 93% probability that at least 1 year between 2022 and 2026 will be warmer than the warmest year on record, which was 2016 so far, and that the 5-year mean temperature of 2022 to 2026 will be higher than that for 2017 to 2021. So these are not very precise local scale predictions, but still useful. There is an increased likelihood of wetter conditions in the Sahel, now getting more regional and local, northern Europe, Alaska, and northern Siberia, and of drier conditions over the Amazon from May to September in the coming 5 years, 2022 to 2026. That's a much more regional prediction, so skill has to be tested, which will start immediately as we go here. So weather conditions in Sahel could be good news, northern Europe, Alaska, but depends on whether snow is getting converted to rain in the winter, or rain is increasing when it is needed. And northern Siberia, of course, could be good news as well if snow accumulation increases, because it's very close to the Arctic amplification, and ice albedo can be very strong here. Drier conditions over Amazon, of course, is not good news, because Amazon gets attention for all the wrong things like deforestation and becoming almost a net carbon sink rather than a carbon source rather than a sink, because of all the perturbations. So near surface temperature anomalies provide a map, so you can look at the regional predictions. This is predictions for May to September 2022 to 2026 relative to 1991 to 2020. Different baselines are picked based on the prediction and where it was initialized. The predictions are initialized predictions, I hope. November to March 2022-2023 minus 2026-2027. November to March crosses calendar years, so that's why it's done this way. But you can see that polar amplification is expected to continue and get worse, maybe here in some sectors over this 5-year period. May to September, bad news continues for parts of Europe, Eurasia, and maybe the tropics here are not seeing such a increase in warming during this period. US West, bad news. Ocean, not much of a news here, but this could be bad news. Does this mean there will be fewer heat waves over Pakistan and India and so on? We have to see, because this is kind of an average of 5 years, so nonetheless it could be useful. The global warming hole continues, the cooling hole continues here in the North Atlantic, and November to March, again, not much of a trend here, but these trends, everything that's plotted is hopefully significant statistically, but you can check. The report doesn't say as much, but you can assume that's what they did. So you can see warmer temperatures generally over the Middle East and North Africa is not good news, and that continues into the other season of November to March as well. Precipitation anomalies, always more difficult to do precipitation than temperature for models for various reasons we've discussed elsewhere. Again, anomalies relative to 1991 to 2020. May to September 2022 to 2026 shows enhanced rain over the monsoon region. Looks like an ITCZ shift here, so wetter on the north, drier on the south. So is that consistent with the drier, wetter Sahel and drier Amazonia? Of course it is, and northern Europe and so on. So look at the season. So this is the November to March season. Lots of rain in some places, drier in other places. So Amazonia is dry in both seasons, which is obviously worrisome. Okay, as I said, precipitation skill can be lower, but nonetheless it's good that initiated predictions for shorter time scales are being made. My own preference is that these are much more on the decision horizons, water resources, food, energy, transportation, whatever. So these are, and you can test the skills, because hopefully even I'll be alive by 2026, so we can see how these predictions worked out in terms of their skill. But doing it repeatedly, and of course these will be updated. This is 2022 to 2026. They will redo it as 2023, 26, 24, or 23, 27, and so on and so forth. So forecast will be repeated, and skill can be tested, just like weather predictions got better at skill over time. We need to improve these skills by understanding why skill is low and what observations are needed, what model improvements are needed, and so on. Okay, so let's leave this here and then come back to emissions gaps in the next podcast. Okay.